Okay, so now we want to send a shutdown command to the motor. To do this, we can place a momentary stop push button switch here, and then connect it to the second channel of the DI module. This is a normally open switch, which means that in normal operation, it is always open. The signal cannot pass through here, and it won't be applied to the PLC. However, when the switch is pressed, this path will be closed, and a 24-volt DC signal will be applied to the DI module. Now, in addition to this hardware alteration, we also need to make a small change to the program. At the moment, the program says that when one of these two inputs is true, the output will also be true. So to shut off the motor, we can cut off the signal that passes through here. To do this, we place a normally closed contact here with the address of the stop switch. The switch is physically connected to the second channel of the DI module, so its address would be IO1. Now, let's save and download the program and see if we can turn the motor off using the changes we have just made. Okay, we press the start switch once. You can see that the motor is now turned on. It's important to bear in mind that the stop switch is a normally open switch, but because we have selected a normally closed contact for this switch in the program, the signal can pass from here, making the output true. One more point to note is that the stop switch we have here is a momentary switch, just like the start switch that we already have. Here we are using a simulator, so to make the simulator's input operate like an actual momentary switch, we just need to make this input true and then make it false again. This simulates pushing the switch once and removing your hand. So let's do this. And now you can see that the signal's passage is cut off in this part, and as a result, the motor is shut off. Now, if we push the start switch again, because this contact is closed, the motor is turned on again. And if we push the stop button again, the motor is turned off. So by adding a stop switch and making a small change to the program, we can control the shutdown of the motor. But I've got a question for you. As you can see, we have connected a 24-volt DC signal to the stop push button. Because this is a normally open switch, the signal stops at the lower part of the contact. When the switch is pressed, the signal can pass from here and is applied to the PLC input. Now, let's imagine that, unaware to us, this wire that carries the 24-volt signal to the switch has been severed or disconnected for some unknown reason. Now, let's press the start switch under these circumstances. As you can see, although this wire has been severed without our knowledge, the motor turns on as it should, so we are still unaware of the problem. Now, let's imagine there's an emergency and we need to shut the motor off immediately. When we press the stop switch, all of a sudden, we realize that, oh no, the stop switch isn't working anymore. So this is a small bug that can cause big problems. Now, in your opinion, what can we do to prevent this from happening?